This is a tutorial video about the particle model of matter that we use to describe solids, liquids and gases. This topic is taught as part of Unit 3 of AQA GCSE Physics and Combined Science, but most of this information is also taught in Key Stage 3, so this video should still be helpful even if you're in Year 7 or Year 8. By the end of this video, you should be able to draw and describe the arrangement of particles in solids, liquids and gases. You should be able to compare the movement of those particles and also the forces between them, and you should be able to describe some limitations of the simple particle model that we use here. The term particles is quite general. It really just means small things, and there are many different types of particles. We represent particles as individual 2D circles or 3D spheres. In reality, those particles might be atoms, in which case the spherical representation is reasonably accurate, but they could also be molecules, which have much more interesting 3D shapes, or also ions, which are charged particles. However, when all we want to do is discuss how these particles are arranged and what the forces between them are like, this simplified model works just fine. The first state of matter we're going to look at is solids. In a pure substance, in its solid state, the particles have a regular arrangement, so they might be put in rows, for instance. And crucially, they're always closely packed together, so every solid particle is touching other particles on all sides. Now, those particles are not stationary, they're not still, they're actually vibrating in fixed positions. So in other words, they can't move from where they are, but they are constantly shaking back and forward. How much they vibrate is related to how much energy they have. So as we heat solids, the particles vibrate more and more. Solids can't flow from place to place because the strong forces between those particles prevent them from doing so. At the other end of the spectrum are the gases. Gases are able to flow and also to take the shape of the container that they're in. Rather than the regular arrangement of particles that we saw in a solid, the particles in a gas are completely randomly distributed. They're much more spread out. And actually, even the way that I've drawn them here, that's too many particles for one box. But if I only drew a single particle, it would look kind of strange. Those particles are constantly moving, and the way in which they move is random. There are much weaker forces between the particles, which is why they don't have to stay together and they're free to move away from each other. By the time you start GCSE, most students are comfortable drawing solids and drawing gases, but liquids tend to be everybody's downfall because there's a perception that a liquid is halfway between a solid and a gas. So quite often students will draw a particle model for a liquid where the particles aren't touching each other. But actually we know that this isn't true. And one of the reasons for this is that liquids are virtually incompressible. In other words, if you put some liquid in a syringe and you try to compress it or squash it, you just can't, because there aren't gaps between the particles that are big enough for the particles to move into. So the crucial difference between a liquid and a solid isn't that the particles aren't all touching each other, because they are. It's that the particles are able to move past each other. So it's rather like if you imagine a really crowded room and you're able to squeeze past people because you're not actually attached to anybody else. So when you draw a liquid, the particles might be a little bit more spaced out, but there definitely shouldn't be any gaps that are large enough for a whole particle to move into. Liquids take the shape of the container that they're in, and they are able to flow from place to place. The reason that the particles are able to move past each other is because the forces between those particles are weaker than they are in a solid, but they're still stronger than they are in a gas, and so that's going to keep the whole liquid together. Hopefully that all made sense. So here's a typical exam question to allow you to test yourself as to whether you've understood this so far. It's 4 marks, so you need to be making 4 points. So pause the video and see if you can now describe the difference between the solid and gas states in terms of both the arrangement of the particles and how they move. In a solid, the particles are vibrating about fixed positions, and they're closely packed together, whereas in a gas, the particles are moving randomly and they are much further apart. Finally, if you're taking the higher tier of GCSE Physics or GCSE Combined Science, then you need to be able to describe a couple of limitations of the simple particle model. In other words, this model is useful for starting out, but what are some of the flaws in it as we start to look a little bit deeper? Well, firstly, in the particle model, we represent all of these particles as solid spheres, and we know that that's just not true. Even if a substance is made of atoms, the vast majority of those atoms are empty space. The other thing that's a bit problematic about this model is that it doesn't actually represent any forces between particles. It assumes that they're just able to move past each other freely. And again, we know that that isn't accurate, and that will become more important as we go further into the Science GCSE. Thank you very much for watching, and I hope you found that a useful introduction to the particle model. If you did find it useful, then don't forget to like and subscribe for more GCSE Physics videos coming soon.